Diego, if you want, you can make me co-host so I
Yeah,
can.
I have already make you Gerardo and Deepa co-hosts.
Great, thanks.
So thank you everyone for joining on time. Welcome to this workshop, a capacity building workshop on national greenhouse gas inventory and short-lived climate pollutants for the waste sector and eco sectors. And this work has been undertaken under the Nationally Determined Contributions or NDC revision process. So one of the requests from our technical advisory group that oversees the NDC revision process was to hold capacity building and training sessions for stakeholders. So we don't just do a lot of research and studies and analysis and produce the NDC document, but we also share the knowledge that has been acquired through the NDC revision process. So today we are focusing on the waste sector, and then on Thursday, we are looking at the industrial processes and product use sectors. So my task was just to introduce and welcome all of you. Then I will hand over to the consultants, Diego and team, to take us through the training. Thank you very much.
Hey, Deepa, thank you. Well, as Deepa said, we will be seeing in detail what we have been doing in the updating of the national GHG inventory calculations. This is including also, this inventory is including also short-lived climate pollutants and other air pollutants as well. So the idea is after this session, if you have any doubt about how to calculate them or how to use the tool that we have been using for this, the idea is to cover all these doubts in the session. So okay, let's begin with the presentation itself. I'm switching right now. So in case there's any problem, please just raise your hand or open the microphone. Okay. Welcome everybody. This is the waste sector session. So as Deepa said, the industrial processes are being reviewing on Thursday. And this specifically session we have 5 parts. At the beginning, we will see the summary of the results that we obtained in the update of the national GHG inventory. And of course, after this session, we will be seeing how to calculate the national GHG inventory. Hopefully, many of you are already familiar with it. But as well, we are including how to calculate SLCPs and other air pollutants, which is something to broaden the scope of the calculations and the estimation for the country. And in the third and fourth part of this meeting, this session, we will be reviewing very deeply and with many details how to calculate different categories in the waste sector. So in these 2 sessions, we will be learning how to use the tool, which things we need to use and update for the next and future calculations. So the idea is in these both parts of the session, I will be doing a brief theoretical introduction to them, and then we will be reviewing the Excel file directly. So in that sense, all the doubts and all the comments, observations, or learnings that some of you will want to learn to share with us. So please feel free to make all the observations and comments, because the idea it's not not to be just from my side the exposition. So also from your side have some thoughts. And at the end, we will have more time to bring up questions and to maybe beginning a final discussion on this. So we will have much time to listen from you. So the idea is you can raise your hand and comments in the proper parts. So again, at the beginning of those parts, I will be giving a brief theoretical introduction, and then more doubts and review itself in deep in the tool. We will be waiting for your questions and comments. Okay, let's begin. We're very well in time. So at the beginning, I would like to show you what are the summary of the results in the national GHG emissions. With this update, this is the big panorama. Taking the emissions from 1990 to 2018, we can see a constant increase in the emissions within the country in this sector, in the waste sector. And we can see that the most important, or the one that have the most contribution to the GHG emissions is the category of wastewater. And therefore we have the second most emitting category, which is the incineration and open burning, followed by the category of solid waste disposal. Biological treatment, as you can see, it's really small. It's even doesn't appear in the plot. So watching this in different numbers, we have different percentage of portions of each category that contributes to the total waste emission. This is a summary for the year 2018, and we can see how important are the categories within the sector. So if we want to see more in detail what happened year by year in each category, we can see that the solid waste disposal has a constant increasing aspect in this case. So this may tell us that nothing special is happening within the sector, within the waste disposal, and we are considering here the increase of population and the increase of the generation per capita of waste as well, and that's why it is increasing. But there is no changes like something really sharp in between 2 years, or something that it's being doing really different. Same happens with the biological treatment, which in this case of Eswatini, it is only including the composting processes. We are not considering, for example, anaerobic digestion, as Eswatini doesn't have. So this is only considering composting, and of course, this is really small plate in the country. So nothing special is happening here as well. About this is a subcategory in the incineration and open burning of waste. This is split in two. So this is showing what is happening with the incineration of clinical waste. And you can see that from 2012, we are having, let's say, increasing a bit sharper than before. And this is because we are considering an increase in the number of clinical beds in the country, and this has a direct relation with how much waste we are generating in the clinical sector. So that's the only difference that we can see here. And in the open burning of solid waste, we are not having any special differences, only including the population growth and the generation per capita growth and so on. On the wastewater category, we are facing the same than before, no special differences here. And so having reviewed all of this, we can make a comparison from this inventory to the previous one, and we can see some differences. Some of them are very important. For example, in the previous inventory, we have more emissions in the solid waste category than the others. So with that view, we can see that, or we will be able to think that solid waste is the most important category, at least before this update. But with all the changes, we can see now that the wastewater category is the most important, or the more emitting category within the waste sector. So this is very important because this helps us to change the approach or the focus on we need to go for taking actions or to improve the data and to improve the information that we are considering for the calculation itself, because this is making us big changes. This is making us a new perspective that probably we didn't consider before. So the idea is to keep improving this information, to have better data, to be sure to increase the certainty of the results that we are gathering. As a big or general comments on this, these changes come from different reasons, let's say. In the solid waste disposal, for example, we update the generation per capita value that what is in use before. These changes, for example, just to raise one of these comments, this changes from 290 kilograms per person per year to 190, so 100 kilograms less per year for person. So this is one of the reasons that we can see difference in here. Also, we updated the global warming potential of methane and nitrous oxide in all the categories. So this impacts also the solid wastes. And also, we update how much waste we are sending to solid waste disposal sites. Before this was really high compared to what we have right now. So that's why the results are changing. Let's say so importantly between two inventories. In the biological treatment and incineration on open burning, there's not that much differences compared to what happened with the solid waste disposal. Of course, in the biological treatment, we have a high percentage of differences, but in total of volume of mass of CO2 equivalent we are emitting, this is not that different. So according to all of this, we can see again that the wastewater category, it's having and contributing the most in this waste sector. So even if this has not been taken into consideration in previous inventory or with the relevance that we are seeing here, this is something that should open our eyes and beginning to improve our information on that sector too, to have more certainty in the results that we are obtaining. Okay, what happens if we project the emissions to the future as we are doing right now? let's say the business as usual. So as well as the summary until 2018, we are facing an increasing of emissions, of course, but there is no special changes, of course, because we are considering here the business as usual scenario. So we will be around 280 kilograms of CO2 equivalent to the final of 2030. The categories will remain in the same portion within the waste sector. And sorry, I have a short in the internet, I think. So yes, no special changes will occur in the business as usual projection scenario. As I introduced in the beginning of this session, we are also beginning the calculations from short-lived climate pollutants. And this is a summary for the year 2018. We only took for show in this presentation the most important, let's say, SLCPs and or air pollutants, and also most emitted heavy metals in the sector. Later on, when we will be seeing the Excel file, the Excel tool, we will be able to see what happened with all the air pollutants and other heavy metals that we are emitting in the waste sector. So here you have a summary for 2018, where you have some numbers just to notice that it is not only important to measure, to quantify how much GHG we are emitting. Also, we need to take into consideration and take the opportunity to measure the air pollutants emissions, or heavy metals and other contaminants that we are taking aware of. So the same that before, this is only the CH4 emissions, the methane emissions for the waste sector. We can see that this is an increasing category. And of course, in the projection, this will remain the same. The methane emission, the methane, it's a SLCP as well. So it has a big relevance when we are talking about climate change and the emergency that we are facing right now. Another SLCP that it's present in the waste sector, and the last, it's a black carbon, which is an important emissions that are coming mainly from the open burning of the waste. Other air pollutants that we have measured, it's non-methane volatile organic compounds. This can be found also in the waste sector, and we summary as well the particulate matter 2.5 emissions in here, which are also present in the waste sector. So this is just a summary, and in the Excel file, all the air pollutants and more details on them can be found, and we will be able to watch them later. So, okay. Now in this part, we will be reviewing how to calculate the big introduction of national GHG inventories, and how to calculate SLCPs, and how to include other air pollutants as well. So this part, we will be learning in the big panorama how we can use the tool, how we can use the methodologies, and then later this session we will be learning how to apply them to any category in the sector. So at the beginning, I would like to say that greenhouse gases are important to measure. Of course, we are facing a climate change emergency right now within the world, but this gives us the opportunity to also be considering other pollutants, other problems, let's say, that we are emitting right now. and this is the air pollutants. And at the same time, there are some short-lived climate pollutants. This is a specific, let's say, separation or specification of some of them. In this case, for greenhouse gases, we have two short-lived climate pollutants, which are methane and also the HFCs. So at the same time, methane and HFCs are short-lived climate pollutants, and they have global warming potential. By the other side of short-lived climate pollutants, we have black carbon and tropospheric ozone, which are short-lived in our atmosphere, but they don't have any global warming potential, so they remain as air pollutants. So this is a maybe explanation of what is the short-lived climate pollutants. And in the air pollutants bubble, we can see many of them, surely we have listened from them before. Let's say the nitrogen oxides, sulfur dioxides, particulate matter, etc. So how to calculate them? So firstly, we will be focused on two methodologies. The first methodology at the left is the Intergovernmental Panel on Climate Change, which is more known as IPCC. And also we have the methodology of MEP-EEA. This is the European Monitoring and Evaluation Program, and with the European Environmental Agency. And we can see that the greenhouse gases are going to be measured with the IPCC methodology. Meanwhile, the short-lived climate pollutants and air pollutants will be quantified using the MEP-EEA methodology. So this is a separation with two methodologies. But the good thing that, and we will see more details after, it's both methodologies can have they are coherent among themselves. So they are complementary. So we are not having any trouble when we want to apply both methodologies. And if we are already measuring the inventories, the national GHG inventory, so they give us the opportunity to keep continuing the calculation of the inventory of short-lived climate pollutants and air pollutants as well. Okay, so the first methodology we talked about was the IPCC, and the general context is IPCC. It's a United Nations body, and this is the unit in which the assessing of the science it's to the climate change it's being developed. So this is the panel that provide the calculation guidelines for the developing. Okay, so this methodology, these guidelines separates the calculations of emissions within a country in 5 volumes, which it's considering 4 sectors of the economy. So the first volume, it's a general guidance and reporting. This is the first approach to be involved to the methodology and to learn how to apply, and an introduction how to use it. And therefore the following 4 volumes, each volume is considered to cover all the sectors. So we have energy sector, industrial processes, and product use that will be reviewed on Thursday, as we said in the beginning. And the 4th volume is agriculture, forestry, and other land use. And at the end, the last volume of these guidelines is the waste sector, which is the one we are covering here in this presentation. Okay, this is a big question, and how should we using the guidelines of IPCC? So at the beginning, we should notice that the most updated guidelines of IPCC are from 2006, and this is the root. This is what provide the methodological basis for the development of the calculation of a national GHG inventory. I just left the link there, and to future review after this session. And but this is not all. We cannot stop and just applying directly the guidelines if we don't consider the following aspects. So to maintain the validity of the sciences that have been developed in the IPCC, over time, we are having refinements, updates, and corrigendas. So these have two ways of how to operate. So you can see at the right side in the red dots that we have had already 12 corrigendas. This is correcting some chapters, some of them correcting all the chapters, some of them correcting one chapter, some part of the chapters, and these corrigendas have already been inserted in the guidelines. So the only thing that we need to consider here is when we are downloaded or maybe we have the guidelines in our storage in our local computer, let's say offline, we will be only requested to from one side update what file we are using for the guidelines, and also to make sure that the last corrigenda that we are that the IPCC made to the guidelines is already considered and include in the guidelines that we are using. This is important because sometimes maybe mistakes can happen. Even this is a big panel and this is very important, and they make many revisions. Of course, some mistakes can happen, and so that's why we should be always comparing the corrigendas. And we know that mistakes happens. We have two examples of them. Firstly, some direct mistakes can be corrected by a corrigenda, as we can see that the panel has already been doing. And also, we have found in a tool, in the waste tool, an error when using it directly. So we know that mistakes can happen. So please only do not rest in this expert panel. It's not making any mistakes. So always we need to confirm that the version that we are using is the most updated and the corrigenda are properly included. So that's the corrigenda thing. By the other side, we have the refinements, and this is something really important because this update of the national GHG update included the refinements, and this was one of the focus of how to update this specific inventory. And in this year, there were it was needed to include the refinements. The refinements were done on 2019, and these refinements apply over the 2006 guidelines. But the important thing here is that these refinements are not directly included and written in the guidelines. So this needs to be used as a complement to the guidelines and not as a replacement as it's written there. So we will be seeing two documents at the beginning: the guidelines itself, the 2006 guidelines, and at the same time we will be the need to use the refinement, which is a complement. So there are two documents we need to see at the same time and should be used together. So what are these refinements? So these refinements has three main focus. The first is, as I mentioned, this is a supplementary or complementary to the methodology. And this is covering the gaps on where maybe new technologies or processes have emerged during the time. You know, the technology is updating and developed really fast. So considering that the guidelines are from 2006, we have new technologies or we have new processes that we need to take the factors of the values for them. So this is what the refinement are doing from one side. As a second objective, this is updating some values by default that we are using in the guidelines. This can happen because we have better or scientific information, because maybe the same technologies that we mentioned before are being updated, so their latest values of this. And the third and last focus, we are giving some additional considerations or broaden the scope of some categories or subcategories, or maybe giving some guidance in case of there is an update of information. So the refinements are covering different objectives. Maybe the guidelines of 2006 will remain the same for a couple of years. Maybe they will be updated. We don't know. But the idea is always be familiar with if any refinement is coming from the panel again, or if the guidelines are going to be updated. So as a general comment, it's always be involved with the panel and seeing the news from them, and of course watching what documents, methodologies they have been updated, and of course the corrigendas. So now talking about the calculation methods of this methodology. At the beginning, I would like to say that the common metrics of the United Nations FCCC recommends to use global warming potentials that are being updated. So right now, this recommendation, it's using the RAR5 report. This is the fifth assessment report. And you can see here that, for example, in these two GHG, as methane and nitrous oxide, we have a big difference among what we have been using before in the previous inventory and what we are using right now because of the recommendation of the IPCC. So in any update of the inventory, we should be taking into consideration if there is any update on, for example, the global warming potentials. Something that could sound really simple, but it's really important, because if you calculate the differences from, for example, from methane going from 21 to 28, this is a huge difference, you know. So we need to consider this always. And in the calculation methodology, we need to always be using again the refinements for all the categories to the guidelines. The guidelines by itself, if we are not using the refinements, can give us, of course, a good approach for the calculations that we are making. But when we want to compare with, for example, other countries, or for example, if we want to reduce the uncertainty of our values, there is a must to consider the refinements. So from now to the future, the refinements should be always considered. So in the IPCC guidelines, we have different calculation tiers. So this is the level of the complexity and the detail that we are having with our information and our data to calculate our emissions. So the first level is the most simple approach. This, of course, has the highest uncertainty and the lowest accuracy. What happened in the level 1 is that the country do not have too much data available. So we are using default values. We are using default activity data that come from estimations from international bodies, for example. So of course, the data that it's gathering from international bodies is not always the most specific, and always the local data that can be raised in local studies it's preferable. So since we are going and developing more monitoring aspects within the country, while we are gathering and collecting more information, we will be step by step being closer to a further level, let's say tier 2 or tier 3. So if we advance to the last level, this is the tier 3. This has the highest complexity. Even the methodology here change a bit because we have new data to use. So the how to calculate some of the categories change, of the structure change, and then the last tier, it's something like a new methodology by itself. But the good thing is the calculations are very representative of the reality, and the numbers that we will be gathering when we be able to apply the tier 3 give us a much better approach of how we are performing in the missions in the sector. And something, just to a general comment, most of the refinements to the 2006 guidelines are related to tier 3 methodologies. So this is a good thing because we're having more methodologies to be incorporating a higher level of calculation. So the IPCC somehow it's wanting from us that we go further to the complexity of the calculations. And here we have an example of how can affect the different tiers. In this case, we brought an example for the incineration and open burning of waste. This is a category, and we have the different tiers here. And then you can see, for example, what happens if we have only at the bottom of the table in the purple row, what happens if we have only default information, and for example, only we have the country-specific total waste amount that we are, in this case, burning. So in this case, even we have one of these data being country-specific, this is always tier 1 level, let's say. So as well as we are able to incorporate or to include more country-specific or local values instead of default values, we will be going to a higher tiers and level of specifications. So as you can see, the tier 3 methodologies are really specific, and even some of the parameters can be are taking into account the specific management of, for example, a plant, so a factory, a facility. So in this case, this is very, very intensive in resources. This needs high data collection, this consuming more time, this needs more people, etc. But of course, and again, this is much more representative for the reality. I just added a note in the last. It is important that no approach is wrong. We want to go further to have better and improve calculations for the emissions, but we need to begin from one step, and that first step, of course, is the tier 1, and then probably we will be on tier 1 for a while, and then in every category and in every sector we will be step by step including new information, which is country specific information, and we will be let's say going to further and higher tiers, as well as as we are doing baby steps, let's say. So the first is having a good estimation of tier 1 emissions, and then with the time and with using more resources in the objective of having more representative information, we will be able to go higher and higher. So now we changed the methodology, and now we are seeing the guidelines to calculate the SLCPs and air pollutants. So it is remarkable that the national GHG inventories should also include GHG precursors and indirect emissions, let's say monoxide, oxides of nitrogen, non-methane volatile organic compounds, and sulfur dioxide. So this is important to begin to include in the emissions in the inventory. So as I said at the beginning, we have the option, we have the opportunity here to broaden our scope of what we are quantifying. So the IPCC is very well coherent with the MEPEA guidelines to estimate these pollutants. So these two methodologies can talk between themselves. So they are complementary, and the guidelines of MEPEA has an early version, but now they have updated this just on 2019. So I just left the link there to see them, and this is the same structure. This has the same structure as IPCC sectors, of course, because they can talk among each other. Sure. So we have sectors and chapters for the energy, AHOLU, IPPU, and waste. But as well, this is including two additional chapters. Sorry, one additional chapter, but this is including natural emissions. This is volcanoes and forest fires. So this is really interesting. So these guidelines can give us, of course, as well as the precursors of GHG, as we mentioned, we can estimate short-lived climate pollutants and other air pollutants as well. So which are the SLCPs? Well, as we saw in the beginning, SLCPs is a new tag, let's say, that takes one part of GHG, let's say, pollutants, and at the same time takes two air pollutants that do not have any global warming potential. But they have a short-term high impact on climate or air quality. And at the right, we can see which substances of SLCPs, which are four, which is the lifetime of them in the atmosphere. So for black carbon, it's only days. Methane, it's 12 years. This is important because all the time we are talking about the global warming potential of methane, which is 2028 in the last assessment report, fifth. We're talking always in the global warming potential that has in the 100-year evaluation. Even that the methane by itself has a lifetime of 12 years. So this open our eyes and say, okay, so we are estimating this in 100 years, but the right thing is this is occurring in only 12 years. So what happened if we consider less period, less years of the period of evaluation? Of course, the global warming potential will raise. So if we are talking about, for example, the global warming potentials in 20 years, the methane has something close to 80 in the global warming potential compared to CO2. So that's why taking account the short-lived climate pollutants and phasing down them, it's something important because it has a huge impact on climate change. As well, we have two air pollutants, which is tropospheric ozone and HFCs. HFCs has global warming potential, so this is also a climate pollutant, let's say. And as you can see in both climate pollutants, we have methane and HFCs. So they have a global impact, a huge global impact, but not that much in local and regional. Of course, methane has. And air pollutants by the other side, as black carbon and tropospheric ozone, have local and regional higher impacts than the others. They also have an impact on a global, but it's lower than the climate pollutants. So as we saw, there are two climate pollutants, which is methane and HFCs, which are at the same time considering GHG and SLCPs. So the MEP EEA guidelines has the objective of calculating or estimating the remaining, let's say, emissions that are not being considered in the IPCC guidelines. So always the methane and HFCs will be calculating using the IPCC methodology, and all others, SLCPs and air pollutants, will be accounted within the using the MEP-EEA guidelines. So as a general comment and perspective, the rest of air pollutants of SLCPs and SLCPs will be calculating using the same methodology and the same approach than the IPCC. So this is let's say kind of easy to being applying them because we will be using the same structure. And the good thing is that we also have tiers here. So we have default values to beginning our calculations, and time by time we will be able to improve the activity, the data that we are using. So we will be increasing our level of complexity, and again making our results that we are obtaining more representative of the reality. So going back again to the IPCC guidelines, now we will show how to use them as a summary before we will be going deeper to the Excel files. So again, and giving a summary, the first step is obtaining the most recent or most updated guidelines volumes. each sector we are calculating. In our case, going to that link and searching for the waste chapters. And remember that we need to not use immediately these guidelines without considering the most updated default values, which are in the refinement, which is the step number 2. So in this first step, understanding the methodology and knowing which kind of default values we have and which emission factors will be induced and which kind of information we need to calculate our emissions. All of this can be covered only with the guidelines. And after we know how the guidelines works and which emission factors we have, how the default values are, which information I will be needing. After all of this, we will be able to beginning our calculations, and we will be taking into consideration the most updated default values and emission factors in the step number 2, which is the use of the 2019 refinements to the 2006 guidelines. So if we don't consider the refinements, when we will be using the step number 1 by only the step number 1, we will be having not updated default values, maybe not updated emission factors. And in case we are going to tier 3, for example, we will not be covering all the methodology that it's available right now, which is in the refinements. So always use the guidelines and their 2019 refinements together, and this is really, really important, and please do not forget. And as a general aspect too, for the MEP-EEA guidelines, this is at the right, you can see an image in which how the waste sector is divided. So you can see that the subcategories that we have within the waste sector. If someone of you have experience with the IPCC, has this kind of the same structure and in the same categories. So this helps us to develop at the same time 2 inventories and to complement themselves. So for each chapter, we will have the same. This is just a focus on waste, but it is very straightforward for all the chapters. The good thing is at the same time they can be used together and they are complementary, both methodologies, IPCC and MEP-EEA. The information that we need to input here in this guideline is the same activity data that it's being induced in the IPCC. So in some few times, it is not the same data. So in that specific opportunities, we will be in the need of collecting additional information to calculate that specific part. But mainly the same activity data for both methodology is used. So that's a good thing. Okay, so we are ready to go to the next section. And after this, we will be presenting the Excel by themselves and how they were calculated and how to understand the tool which we will induce for the future calculations. So this is really important in how to do the update for future estimations and calculations. So we will be going through each category within the waste sector, and I will be waiting your participation in them after the theoretical introduction. So now we will have and specific in the waste sector, as we said. And on Thursday, we will have the IPPU review of the compilation file. And this compilation file, it's gathering all the information that, or the activity data for that we need to calculate. And of course, it also have the emission factors, and it has all the formulas and equations that are applicable to the country so far. So this is the root of how we need to calculate the emissions in the future. So all the information should be included in this compilation file. So we will not need to have in separate Excel files or tools or other Excels that in which we will be making the emissions estimations. So this is a big, let's say, compilation file. It is organized as we can see at the end of this page. We have parameters which will include all the constants, global warming potentials, emission factors, conversion factors, which are very important in the calculations, and all the other tabs within the compilation files will call to the parameter tabs. So this is very important because in one Excel file we will have many tabs for each subcategory within the waste sector, right? So if we change a parameter, we will be able to be sure that this parameter will affect all the tabs, let's say downwater. So having this kind of tabs helps us a lot to just update for future global warming potential, contents, or emission factors just at one side, and will impact all the calculation too. And later, we will see that we have also tabs for summaries. For example, GHG and SLCP and air pollutants summaries, which will allow us to have, we can plot graphs there. We can have we can see all the time series at the same time for all the waste categories. So that's a good to have a big panorama. And at the latest, we will have all the tabs for each category or subcategories, and in which all the calculation it's taking part. So this is what we will see in the next section. And right now we have a short break. So I will share my screen with the agenda, so everybody it's able to see this. And we are a little past on time, but we will be able to have a short break. So we can take a 10 minutes break right now, and then we will back on time at 3 p.m. and 20 minutes. So I will bring this agenda, and you now have 10 minutes of break, and then we will be going deeper to each part of the categories to review the calculations. Thank you.
Thank you, Diego.
Sorry, if everybody's here still, Deepa suggests us to just having 5 minutes break, which it fits to me. So let's change this and have 5 minutes break. So take your rest, and we'll be back here in 5 minutes, please. Thank you. Okay, we are on time, so hopefully people is coming back. Now we will be able to continue with the part 1, the review of categories for A and for B. So okay, if Deepa, do you agree that we should continue?
Yes, I think we can continue. There's one or two colleagues who have emailed me saying they were invited, but they haven't been able to join. So I'm just resending the links. But I think
Okay.
you can start.
Okay, I will start. Thank you. I will be beginning with my mistake. Just a second. Okay. No, it's well. This. Okay. Here we go again. Okay, in this section, we will be reviewing how to calculate the categories for A and for B, which is the solid waste disposal. That is the for A, and for B it's the biological treatments. So we have at the beginning the solid waste disposal category, which is the 4A, and as we saw in the beginning, this is one of the volumes, the waste, and within the volume, we have different chapters, and each category has one chapter for each category. So in this case, the step 1 will be, as we mentioned before, obtaining the guidelines, the 2006 guidelines for this chapter, for this category, in which the link is written down there. And then step 2 is considering the refinements to the guidelines for the chapter. So that will allow us to have the most updated default values and emission factors. And as a third consideration for this category in specific, this chapter includes also a tool to calculate the methane emissions from solid waste disposal sites. So that tool, that a calculator, it's named IPCC waste model, which is made on Microsoft Excel. And this tool helps us a lot when we want to calculate the emissions from solid waste disposal sites. So this tool is making things easier for us. It's a really useful tool. The only comment I would like to add here is this tool should be used carefully. As I mentioned in the beginning, we see an error in this tool. This is a really, let's say, small error, but this is only noticeable if we check the values that are being used. This is if we rest on the trust that the IPCC hasn't made any mistake, so we can see that an error could occur in case that we are not checking what values we are using. For example, the tool, as we will see soon, has default values by regions. For example, in this case, if I will select the Southern Africa values, the tool will not send me the the values for Southern Africa. So, but it will send me the values for Middle Africa instead. So that kind of error can occur. So as you can see, it's small mistakes, but what will happen if we don't check that the values that we are using? So the tool, this tool should be used always carefully, and hopefully this kind of mistakes, they are being covered by the IPCC, and they are fixing them. So another consideration for this category, when we are considering the solid waste disposal, it is important to know that the waste will release the emissions during or within decades or many years, let's say. So the waste that we are disposing today in the solid waste disposal site will release emissions for many years in the future. So if we want to know the emissions today, we need to know what happened in the past. So a really good practice is a desirable practice is having 50 years of that activity, if of course that activity is available and it's applicable, because maybe some solid waste disposal sites do not have that years of activity, but the most years of that activity we have, that's better for us. Of course, in the past, these kind of estimations and this activity data hasn't been covered or gathered. So some estimations we can have to cover those past years, and hopefully from now to the future we will be able to gather more information for future. And in this specific category, the main activity data that it's needed and some potential sources of information is the population, which information can be taken from the Central Statistics Office or Census, and the generation per capita of waste. In this case, as we are facing two things. The first is we need historical data to the past years, and of course, at the same time, some activity data we are lacking of it. So we needed to make some estimations using the gross domestic product, the GDP, and methodology from the Waterways 2.0, which is from the World Bank Group, and the link you can see at the end of this page. And this estimation helped us in obtaining a generation per capita, taking into consideration, of course, the population from one side, and the other side, the gross domestic product. As soon as the municipalities and the central government will beginning to gather more and more information, or requesting to the industrial maybe sector to report the waste generation, we will be having more local specific data, which will help us to have more representative and more certainty in the results. A third activity data that it's needed is the fraction of municipal solid waste, in this case, disposed to solid waste disposal sites. And in this case, it's remarkable that the fraction of municipal solid waste being traded under different alternatives, not only solid waste disposal, but also in the biological treatment, and also in the open burning, and also how much of the municipal solid waste is going to recycling. This should be considered all as a mass balance, let's say, and all of those treatments and many others that may be happening in the future should be accounting for the 100% of the municipal solid waste, because every unit of municipal solid waste should be receiving a treatment, even if we don't know with much certainty what is happening with that. But we need to make all that mass balance. And in this case, in this update, we did this mass balance using a local source of information. And at this at the same time, we have regional default values, but maybe some of them are not that applicable to the country. For example, in the IPCC, we can have near to 70% of municipal solid waste for Africa that's going to solid waste disposal sites. But this is big influenced by South Africa. Maybe the practices that are being doing in that country are not that representative in all the waste management. So should be take used with care. Also, there are some specialized source of information, as I mentioned before. The water waste document, it's a really good one source of information, but it is always to use that if we have some kind of support documents to demonstrate that that fits better to the country's reality. At the same time, we have as activity data needed the composition of waste that it's going to solid waste disposal sites. In this case, the composition of municipal solid waste, it's the same considering to all the categories, which maybe it's not the most representative because the solid waste that is being disposed maybe has one composition, and the solid waste that is being burned has other composition, and the municipal solid waste that it's being recycled has other composition as well. So as a first tier level of information, it's enough and good enough. But with the years, hopefully this composition will be being adjusted to each category or each, let's say, subcategory in the waste sector. And also, what happened with the solid waste disposal sites? So, as we know, there are different solid waste disposal sites with different kind of management, and some of them are anaerobic sanitary landfills, well managed or poorly managed with engineering. Some of them are dump sites. Some of them has better and higher technology, which, for example, can be semi-aerobic landfills, and etc. So all of them has a different or creates a different environment to the emissions. In this case, the different kind of solid waste disposal sites and which is the distribution of them, which maybe sometimes it's not that known, will make us more representative estimations for the emissions. So in an ideal world, each solid waste disposal site should be identified by the central government or by the municipality, and know how that solid waste disposal site is operating and how important in the country it is. And this is how much municipal solid waste it's being treated under that solid waste disposal site. So of course, as big the solid waste disposal site is, the big relevance to the country that will have. In this specific case, that in this category we have solid waste disposal sites, and which is one of our mitigation actions proposed. It's installing landfill gas recovery systems, or for example, for flaring. So those kind of solid waste that will have in the future landfill gas recovery system, they will be reducing or mitigating methane, let's say, for example, recovering methane or flaring directly. So those emissions should be deducted from the methane or the raw methane emissions that will be estimated with the waste model tool. So as we will see in the model tool itself, that has um, an option in which we can add how much methane it's being recovered or burned. So now, having this in mind, this is one of the mitigation options that we will propose at the end of our job, and all the reductions should be accounted. So later on, we can see that the solid waste disposal sites will have lower emissions in case that we are installing landfill gas recovery systems. And at the same time, for future improvements, for example, is that in case that industrial waste will be beginning to be estimated, it can be inputted also in the tool. In this case, the industrial waste can be estimated using the generation rate of industrial waste per unit of gross domestic product. So different ways to approach this can be followed, but as a simple idea, the industrial sector could estimate how much waste they are generated compared to the gross domestic product, let's say total market value of their finished goods and services within a year. So uh, this will need the a cross between the economics and the production, and then a measuring of how much waste we are generating by the industrial sector. And then that can be included in the future in the tool too. And as a last comment, the waste model tool will estimate only the methane emissions that are emitted by the solid waste disposal sites. And then, of course, to include in the national NGHGI inventory, we need to estimate them in CO2 equivalent mass. So the next introduction to the category that we will be reviewing, the Excel file, it's the biological treatment of solid waste. And again, the step number one will be having the guidelines, and then the step two will be gathering the refinements. But in this case, there are not applicable refinements for this category. So in this specific case, with the guidelines, it's enough, and that's easier for us. And in Eswatini, the organic matter that it's managed under biological treatment, as was mentioned, it's only composting. For example, anaerobic digestion, it's not considered. So the activity data that it's needed for this information, now we are able to see that some of the data that we used in the first category, the 4A, the solid waste disposal, we will be, let's say, recycling that information and using the same, for example, the population, which is the generation per capita. In this case, a mass balance was performed to obtain the fraction of municipal solid waste managed under each category: solid waste disposal sites, biological treatment, open burning. And so it's the same mass balance at the same time. And okay, as I remember, this session is being recorded for a future review. And now we will be reviewing the compilation file and checking how we calculate and obtain the results. And these two files, the compilation file and the waste model tool, will be available for future calculations for you. So hopefully you will be able to focus only on what we will be reviewed. So now I will switch to the famous tool that we talk about. I need to stop my share and do something. Okay, just a second. Okay. Okay, this is the waste compilation file. So I will make this as big as I can. And as we can see, this compilation file has many tabs in the bottom, at the bottom. So this is all these are all the tabs that we have here. So we have, I will begin from the last. And these all tabs that I'm selecting right now, each one of them are for each category. So we have solid waste disposal, we have biological treatment, incineration and open burning, which is split into incineration of clinical waste and open burning of municipal solid waste. And then we have the calculations of wastewater, which is split into two as well, which is methane emissions and nitrous oxide emissions, and calculations for SLCPs and air pollutants. So we will be focused only in these two tabs at the beginning, but as well, we will be seeing how the parameters looks, how the summaries of GHG emissions and SLCPs and air pollutants looks. So also we have three beginning tabs, which in the compilation files that we received, those tabs were not being in use that much. And since this tool is being to be used by your teams in the future, we only left them, these tabs, and trying to complete them. But these are just for follow-ons of who used the tool for the last time, which notes we need to take into consideration for the library. For example, when was the last date of update, and all of this kind of let's say management of the project can be done in different routes. So in this tool, we focus in the improvement of how the results are being shown, how the parameters are being used, and updated all the calculations for each category. So let's begin. Just a quick check of what is happening in the QH sheet. So this has some information, which is the status, which was the recipient, when was the date of reception, and some explanations. But this is something that it wasn't being in use when we received the compilation file, and considering that the same people that were in use before will be using this tool again, I think you are already familiar with this. Okay, so going directly to the estimations and to the calculations. At the beginning, I will show how the summary of GHG it looks like. So this is the waste sector, and we are considering all these categories. The time series considered it's from 1990 to 2030. We have those climate pollutants, and here we have the last edition, sorry. And now here we can see in units of gigagrams of CO2 equivalents what happened with each of these categories: solid waste disposal on land, composting, incineration, open burning, and wastewater for each year. This is what is happening for each year. And then we can see that this is running until 2030, but the tool itself has more years for the future if you need to. And this is the sum of all sectors. So now we have the tables here. Some of them I have already showed you in the PowerPoint presentation that I gave before. And this is what is happening with for the year 2018, for example, with for each category, and this can be updated for each year that you need to show, just modifying the formula. And this also we show that a comparison between previous inventory for 1 year with the updated. So this tab, the GHG summary, it's also plotting some graphs, and then as soon as you need to plot some graphs, you will be allowed to do this in this tab. So that's a fast review of what we have here, and in a really similar way, we will see the same in the SLCPs and air pollutants summary, which were calculated using the MEPEA methodology. And we, in this case, in this summary, we only focused on the main pollutants. This is methane emissions in the waste sector, which is in tons of methane. And we have black carbon emissions as well. We have non-methane, volatile organic compounds emissions, and particular matter of 2.5 emissions, which all of them were shown in the presentation as a summary using the same tables, you remember? So you will be able to see what is happening with each of these air pollutants and SLCPs alongside the years. As you can see, for example, black carbon emissions, they only comes from incineration and open burning, and mainly only from open burning subcategory. And by the other side, the methane emissions came mainly from three sources, which are solid waste disposal, the open burning of municipal solid waste, and in the wastewater treatments and discharge. And as you can see, one of the most emitting subcategory here is the wastewater emissions. And also, when we talk about non-methane volatile organic compounds and particulate matter of 2.5, which are very harmful for our environment and our health, we can see that mainly only the open burning of municipal solid waste is the contributors to both of these categories. So it's the same that happens with the black carbon emissions, you see, and at the same time, it's a big contributor of methane emissions. So this is one category that it's being really intensive, not just in terms of GHG emissions, as we saw that it's not the most important, this category, the open burning, but it has at the same time a huge impact in other emissions, not only in greenhouse gases, also air climates, pollutants and climate SLCPs. So to continue, in the parameter tab, in this tab, I will give a bit of zoom. So we have many parameters here. We have conversions and global warming potentials of the greenhouse gases being used in this tool. We have waste emission factors for the GHG accounting, GHG estimations, sorry. And at the same time, we have the waste emission factors for calculating the SLCPs and air pollutants, which are being used, these emission factors are used for the MEEA methodology. And all of these emission factors for calculating the greenhouse gases are the one being used for the IPCC methodology. And at the end, we left here the mass balance of how much municipal solid waste is going to solid waste disposal sites, how much is going to biological treatment, how much is being open burned, how much is being recycled, and then the total of municipal solid waste that's being treated. So here, these are the main categories. And the idea is, in case that you need any new parameter, you can add any row here, for example. If a new conversion you can insert always a row here and just filling the description and activity, the units that are being in use. Here we have what it's being converted from something to another thing, and a specification if this is a default value or is something country specific. In this case, of course, emission conversion factors and global warming potentials are just default values. And in case there's some data source to be reported, we can add here in this column. Some notes can be added for each parameter too, and then each parameter has the value for each year. So this is made for all the years within the time period. You can see that in this case, we are watching 365, as you can imagine or remember. This is the days in a year. Of course, this will not change in any year. This will be the same for all years, and all the conversion factors and the global warming potential will remain the same for all years. But we will see that some factors can be changed into if things happens and we can measure it. So that's important why this is not only a fixed value for everything, even most of them have the same values for all years. But this can be updated in case we know that from, for example, 2025, things will change in one of these parameters, and then we will be able to change them from that year to the future. So in this case, the parameters takes the information mostly of general emission factors. Specific activity data will be used directly in each tab. So the idea is that if one future refinement, for example, or one future guideline, if that appears, makes the need of changing one emission factor, then we can come to the parameter tab, and then change here one of those. For example, I don't know, this will change to 90, and then I need to all change to 90, and then I can then drag everything really fast, and this will impact all the tabs in which it's being used. So imagine that, for example, this mass balance, which is in the end about how much municipal solid waste is being treated under different alternatives. Imagine this change in the future, and this information will be in each tab. For example, solid waste, and then biological treatment, and incineration and open burning, etc. So if I forget, in that case, to change in one of the tabs, so the mass balance will not be well done, the calculation will not be well done. So this is really important to have the general parameters being all together in just one tab, and then use this tab and all the following tabs in which the calculation it's made by themselves, by itself, are referring to this parameter to as high as we can. Okay, so having reviewed these general parameters, I will not stop in seeing what emission factor each one of them, but this is all the emission factor that the methodologies need. So let's go for the first tab. And this first tab is the solid waste solid waste disposed of, and then we can see here different rows. The first is the activity data that we need. So which is the activity data that we need? As we saw, it's the population for each year. In this case, the population will change alongside the time series, as we can see. The generation per capita, we made an estimation using a water waste source. This is the column of sources and nodes. And in this case, this changes from year to year. So you can see here in 1990 that we are close to 180. And then today we are having 195. So for example, this is something that in this case now is changing year by year, but this was fixed. This has a fixed value for all years in the previous inventory. The previous inventory accounted here for 290 for all years. All of these years have the same value. But this is something more representative because, of course, generation per capita behavior changes. Hopefully, if we implement more education programs and awareness raising, this generation per capita can be even lower in the future. Hopefully, that can be seen later on. So now we can see how much municipal solid waste is being landfilled with this activity data, but at the same time we are using some parameters. So in case that we need to update the parameters, this will affect to these calculations at the beginning, at the same time. So this is the second section here is which are the emission factors that are being induced for calculating the SLCPs and air pollutants, and these are taken from the parameters. Again, this is only a formula to look in this year, to look for this name of parameter in the tab parameter, and then this formula 6 for what I'm looking for in the parameter tab, and we'll put it here. So as I mentioned, the IPCC have developed a tool which help us to estimate the solid waste disposal emissions in solid waste disposal sites. So this is the only tab in which the emissions, the GHG emissions, are taken from an outside or a file that it's not included here. So you will see here only fixed values. This is not formulas. This is not formula. This is taken from the waste model, which is the most updated with the refinements. And then the only thing that we will have here in the compilation file is the conversion from methane emissions, gigagram methane emissions, to gigagram CO2 equivalent emissions. This is how we do this. Of course, only multiplying the methane emissions by the parameter in the row 20, which is the global warming potential of methane emissions. Okay, so now we will go to see how these emissions are being estimated. So now we will move to the waste model. This is the tool that the IPCC had developed, and this included the refinements. I know this is not in a good color, but this is the refinements that are being included here in this tool compared to the previous tool that they developed as well. So we have here some instructions. This it's really helpful because all the methodology for this category is included here. And this here we have some explanations, and we can learn a bit from here. And then we have general parameters here. So as I said you before, if I will select here Africa Southern default values, I will have some problems when taking some default values. So that's why that's why I used some. I'm not able to use the southern values in this case. Okay, so this tool is asking me for many parameters, in which some of them are just default values and some of them are not. In this case, we are considering 50 years of history. So we are starting our reception of municipal solid waste in solid waste disposal sites from 1970. And this is how much of every stream of waste has degradable organic carbon. So these are default values. As you can see, we are using the same than the default values. In this case, we can have something specific for the country, but this will be something to higher tiers. Again, with the fraction of how much of the degradable organic carbon can be really dissimulated, this also default values that are being used in this case. And again, we have a methane generation rate constant for each waste stream, and this is needing an input of how is my temperature, how is my climate in the country, which is the most representative climate in this case for the country. Is it dry or wet, or is it tropical or temperate? So in this case, we are considering a dry and temperate climate. We made an analysis for obtaining this, and then all these default values are being taken for the default. They are not developed for Eswatini. So if we change different climates, we will see that these rates will change. So this is really important. And again, this is something about default values that the IPCC recommends to use. And of course, this can be updated if we can demonstrate that we have different values that differs from the default values that IPCC recommends, which we would like to use them. Okay, so this is the first parameters, and I will say that the most important here is setting up a starting year, which did that on 1970. Maybe that will be going, for example, maybe this will never change again, because we will only add new years for now on to the future. but it doesn't make any sense to delete what happened on 50 years ago. And I think that the only important parameters here for a tier 1 level is to be to detail which is the climate, because as you saw here, these values all changes, and all of these values will not change with the climate conditions. Only the methane generation rate constant will change with the climate conditions. So then the yellow tabs are the ones that the IPCC have developed in the tools, and the black ones are tabs that we worked and we added here just to make some explanations, but this is not the case to cover them. Then we will go to the next yellow tab, and this is accounting for the methane correction factor. The methane correction factor tells me how is the environment being generated in each solid waste disposal site. So if the solid waste disposal site is being engineered and managed, and the waste are being compacted, and the waste are being covered by covering material, so this will create an environment in which the anaerobic conditions are ready to use, let's say, and then methane emissions will be generated because of the anaerobic conditions in the environment of the solid waste disposal site. But what will happen if we have an unmanaged solid waste disposal site, for example, something more close to a dump site? So that will have a different methane correction factor, and in this case, the methane correction factor will be lower than an engineered landfill. And this is why the conditions or the environment conditions are not that high in anaerobic conditions as in a managed solid waste disposal site is, but it is more aerobic conditions because there's less compactation in the waste. They're not that covered. At the same time, the solid waste disposal site, it is not that deep as maybe can be managed. So the methane correction factor, it's accounting for all of these conditions. And we need to know then how much of the municipal solid waste it's going to different kind of solid waste disposal sites. So this is a recommendation from IPCC, which it's only this was only modified and updated, reducing some of the managed solid waste disposal sites, and then I'm categorizing some of them. So this received a small adjustment, making it more representative to the country. And as you can see, again, this is year by year fixed in a fixed value, but of course, this could be changing year by year. And then year by year, we can be, for example, reducing how many solid waste disposal sites that are being unmanaged we have in the country. And for example, in the future, hopefully we can have semi-aerobic solid waste disposal sites. And then this will be growing up, for example, let's say from 2030, year by year, and let's say step by step. So this permits us to modify it and not have fixed values, but this will depend on how much information we have in the country. And in this case, we have also the industrial part, not only the municipal solid waste, also the industrial. And in this case, we don't have any input in industrial waste because we don't have any data in here. But in case that in future processes would like to add them here, all the structure in this tool, it's available. And you can see here that there's a weighted average methane correction factor for municipal solid waste, which is enough average considering all of these factors, default factors, and how much we're sending them for each kind of solid waste disposal site. So taking all this average, we're having a methane correction factor approximately of 0.7. Okay, and this is the activity data that we need to fill, and the IPCC regional defaults in this case, we are not considering this because we are having our own waste per capita. In this case, I think I already fixed this. So if I use Southern here, it's showing me something different here. And if we take Asia, for example, it's showing me something different here. But we are not using this approach in this case, and we have our own waste per capita estimation that we made using a regression with the gross domestic product. And also we have our own estimation with the mass balance that it's going to the municipal solid waste disposal sites. So we input here the population in millions, that's important. And we input here the waste per capita that we estimate with the regression. And we input here how much of this municipal solid waste is going to solid waste disposal sites in percentage. And all of this composition, it's the same year by year, and this is taken from IPCC recommendations. So this activity data, it's the needed to be inputted in here alongside with the methane correction factors. And then there are two different yellow tabs in which we can have a summary of how much of fraction we have deposits in the solid waste disposal sites. And this also has the opportunity to estimate how much recovery we have made or how much methane has been oxidized in the top layer. In this case, we don't have any recovery in the country. Neither we have oxidized in the top layer. So now we need to go just directly to the results. And in these results, it's taking all the information that we inputted before. And the methane emissions that we are having here are in the gigagram of methane. So we took this information, these results, and these results are the ones that we paste. I cannot show more numbers after comma here, but all of these results were the ones that we took and paste here. So the tool made us the results, and then we throw them to this compilation file. So finally, the last part of this section, this is a really short tab, so it will be reviewed really fast. And then the composting activity in this case will use the same categories, same activity data than before. This is generation per capita, population, and now we are using them from the previous tab. So if we want to update this, we need only to update this in the first tab. And then we have here the how much of the municipal solid waste is being composted. This is estimated in a very low percentage, less than 1%, half of it even. And then we have here the emission factors that we will use. So we have two emission factors, methane factor and nitrous oxide factors, which both comes from the biological process of the biological treatment. And then we have only one emission factor for pollutants and SLCP. So this is this category. It's really, really low in emissions, both in GHG emissions and in SLCPs and air pollutants emissions. So again, then we have the emissions calculated here. This is at the beginning emissions of methane, which is using this emission factor for methane. And then we have nitrous oxide emissions, which is using this emission factor of nitrous oxide. And then this is in gigagrams of methane, this is in gigagrams of nitrous oxide. And then we need to convert this to CO2 equivalent using the global warming potential, which is in the parameters for both pollutants, in this case, methane, and in this case, nitrous oxide. So the sum of them both will give us the emissions within this sector. And it's the same approach for the SLCPs and air pollutants. So this is made for in these two tabs. We now have a short break, and then we will be watching the last part of the revision. And I would like to know if there is any direct doubt here. Someone would like to comment, to observe. Anyway, we will have more time at the end of the presentation again. So I will be waiting for a couple of seconds. Someone wants to open the microphone? Otherwise, we can go and take a short break to go to the last revision. Okay, then should we take a short break again? Let's say 5 minutes again, if that fits. Deepa? I don't know if you are there. Okay, I'm watching my watch. Okay, let's take a break of 8 minutes. And then we will right back here at 20. So for 20, here again, I will write down in the chat. Thank you.
Thank you, Diego.
Okay, we are on time to go back and to continue the presentation. We are on time. So just we will be giving a summary of what we have been doing. By agenda, we are a bit delayed, but the most let's say difficult category we just passed, which is the 4A, the solid waste disposed. So now we will be able to continue a bit faster than before. Again, if you have any consultation on how this tool it's working, and the idea is that after this session you will have more knowledge or more understanding on how to use this tool for future calculations. So if any observation or concern raised on this, please just open the microphone and comment. We have still some minutes for initiate a final discussion. So please participate in this, and if you have any doubt, please we can happy discuss it. Okay, so just a little summary of what we did before. In the first category, the emissions, the GHG emissions comes from the tool that the IPCC developed, and the emissions on SLCPs and air pollutants is all the structure is here, and the activity data that is needed to calculate this is the same that they needed for IPCC. This is the only category in which GHG emissions come from an annex or a file that it's not included into the file compilation file itself. And the biological treatment, we saw that it's a really simple category with really low and a short list of emission factors for both GHG and SLCPs. So in case that any doubt you still have, you will always be able to contact us directly. We will be always available for solving some doubts that will arise in the future. So we will not disappear on this, and you have our contacts to ask some things to us. So the idea is, firstly, if you can raise your observation and questions here, that's perfect. But if some questions will arise after this session or in the future for future calculations, we will be always available for helping on this. Okay, saying that, please, if someone can confirm that I'm showing the PowerPoint presentation. Okay, thank you. And so now at the end of this session, we will see what is happening with the categories 4C and 4D, and later we will have a space to have more discussion or questions. So, which is the category 4C? The category 4C is the incineration and open burning of file. So again, as well as the previous categories, we have a step 1, which is the guideline for incineration and open burning of waste, and we have step 2, which are the refinements. So we have refinements here that apply to IPCC guidelines. So we need to ensure that we are using the most updated information for each topic that it's applicable to the country. And this is split into the first is incineration of waste, and the second is the open burning of waste. The first incineration of waste it's including only clinical waste. So we only have incineration for clinical waste, but not for other kind of waste like municipal, for example. The thing is here, we don't have, for example, the activity data needed for amount of incinerated waste. For example, we don't have weight scales in the clinicals, in the hospital centers, in the health centers. So we are using an estimation using the number of clinical beds that are available within the country. We have an estimation from a local source, which is how much waste it's generating each clinical waste. The Ministry of Health, it's including this information. So hopefully for future years, from these years, I think from 2020 to the future, they are having better information in this sense. So this can be updated in the completion tool later, as we can see in a few minutes. So other activity that it's needed in this subcategory, it's which is the technology of the incinerators that we are using. We can have stoker technology, or we can have fluidized bed, and the important thing is each kind of technology has different emission factors. So if we don't have the information for each incineration facility or plant, so it is always recommended to use something that it's more conservative to our emissions. But we will be always requested to improve the data. But of course, we need to improve the data in all the categories. So it is always to put the efforts on the categories which are the most relevant to the sector. This is, for example, the wastewater category and the solid waste disposal category. So maybe putting all the efforts now, trying to see if the technology is a stoker or fluidized bed for each facility within the country is not that efficient to compare it to knowing further about the categories that I mentioned before. And at last, the type of incinerator which in its operation, which could be continuous, in batch or semi-continuous, will also have an impact on the emission factors. So again, that will depend on each incineration or each facility that is having an incinerator. But going deeper and further for gathering this information maybe is not that efficient in terms of time, in cost, and people that we need to involve in the process. So the second subcategory of the category 4C is the open burning of file. This is open burning of municipal solid waste. And in this case, we are considering, again, municipal solid waste. So we're considering the same information that we used before, according to population and the generation per capita. Again, the mass balance of different waste management alternatives appears here, which is the same mass balance that we are using for the three previous categories. And as I mentioned, each category should have their own composition of waste that it's going to that treatment, in particular in this case, which is the composition of waste that it's being treated under open burning. For example, it is maybe something that could make us a reason, or it's something reasonable to us thinking that the waste that it's being open burned, it's not, for example, glass, it's not, for example, aluminum cans, but they are more about plastics, more about cardboards and papers, and maybe garden waste or branch, but not food waste directly. So that is why the composition of waste should be more representative to each kind of treatment. But if there is no information available, or we are having lack of information in that category, we should be considering just the same composition than the others. In this case, we are using the same composition that the composition of municipal solid waste that are going to the sites. And then we will see at the end the category 4D, which is the waste water treatment and discharge. So here again, we have step 1 and step 2 links that I posted in the presentation. You can review them later. And the activity data that we are needed here, it's a population, again, the same that used before. And here we have something a bit different in the second bullet, which is the total organics in wastewater. So right now we are using default values recommended from IPCC. And the results of this, maybe it's something kind of new. So this is the biological oxygen demand of the wastewater. And also this is requesting us accounting how much of organic waste it's being removed as sludge, or how much of methane, again, as well as in the solid waste disposal sites, it's being recovered. In this case, the recommendation from IPCC is both of them are 0. So in this case, both of them, we are not removing sludge from wastewater treatment plants, neither we are recovering any amount of methane, for example, for energy purposes. So in this case, both values are in 0. Also, the activity data that we need here, it's which is the fraction of the population that we have in urban and in rural areas, in how many people, and how many of them are in the low or high income group just in the urban area. So because that will have a different management, they will have a different management in the wastewater treatments according to the income group. So this assumption were taken from the Ministry of Health assumptions, the sanitization department, and the population segregation was taken from the Central Statistics Office. This activity data that I mentioned recently were needed for calculating the methane emissions for wastewater treatment and discharge. We also have the nitrous oxide emissions. I back again. So we also have the nitrous oxide emissions, and the activity data, it's really similar. And we have here the population that was described in the 4A category. Now we have something particular here, which is the protein consumption per person. I just forgot to add there the potential source of information that we are using right now, but I will after this session. And we are having FEO stats from United Nations of how is the protein consumption per person in each country. So we are taking that information, and then with that information, we can know how much nitrogen we have in our wastewaters. Again, this accounts for how much nitrogen we are removing from sludge. In this case, we are considering 0, which is the default value recommended. And in this case, the amount of industrial wastewater that is being treated, we don't have the specific information, but the default value that IPCC recommends when lack of data it's occurring here, it's considering a factor of 1.25, which is a 25% more of how much we have already been considered in the municipal, let's say, wastewater. Okay, so again, this session is being recorded. and the compilation file will be available for future calculations. So please, all the questions that you are having on this, please raise your hand and I will be happy to answer. So I switch my tab to the Excel file and we will see the last tabs. So just to show you, the category 4C in this case is just a summary for 4C1 and 4C2. And the same will happen with 4D. This category is just a summary of the emissions coming from methane and the emissions coming from nitrous oxides. In each tab, in incineration, open burning, biological treatment, and solid waste, we have a way to calculate not only the GHG emissions, but also the SLCPs and air pollutants emissions, all included in one tab. But in wastewater, we included this only in the emissions of nitrous oxide, and then if that's why this have a different name, just to make the mention of it. Okay, so the first category, it's incineration, and this incineration is taking the activity data that I mentioned before, which is the number of beds, how much of waste generation have each beds of a clinical, and then we can estimate how much clinical waste is being generated in different units here per year. And then with that information, we can calculate the emissions. So just to show you how we made a regression in here to show how the number of beds are being changed alongside the years. And then we saw at the beginning of the presentation that we have a little increase at the end of the years. This is why that's why we are having an increase on beds, and this is why the number of beds in Eswatini has increased, and the last time more quickly, rapidly than in the past. And the rate of clinical waste generation per bed per day, it's a fixed value on 0.2 kilograms of wet waste per bed per day. If we have better information, or in the future years that changes, so that we can always update the values here and everything will change. And then this is a calculation for using the activity data and conversion factors and global conversion factors. And again, this is using conversion factors again. Okay, so also again, we have emission factors for GHG emissions. And you may see here which is the source of these values. And then you can go to any of the tables of the IPCC guidelines to see if something changes, if you want to review this. At the same time, the emission factors for from MEPEA for calculating SLCPs and air pollutants can be found here. So always you will be needed to check if units are the units that we are using for the emission factors are coherent with the units of the activity data that we are using. In this case, if this needs megagrams of waste, for example, then we should be using megagrams of waste, which is this row. All of these use a megagram of waste, so we will be always using this row, which has the units that we need. In this case, the emission factors of GHG emissions as well should be in coherence with the activity data that we are calculating before. Otherwise, we will be not be doing a well, of course, calculation. So when we go to calculate the emissions, let's say the GHG emissions or SLCPs and air pollutants emissions, we have the structure here, and then we can firstly know how much CO2 directly emissions, this is not equivalent, this is direct CO2 emissions we are having in incineration, and then how much methane emissions we are having in incineration, the same with nitrous oxide, and then all the conversions to, in this case, from methane to CO2 equivalent, from nitrous oxide to CO2 equivalent. And of course, there is no needed to translate this, let's say, and then this is the sum of the previous CO2 equivalents in this case. And the calculations here appears for the SLCPs and air pollutants emissions. So this is the incineration. As you can see, we have many emission factors here for different air pollutants and SLCPs. So something to take into consideration, not only in GHG emissions, but also in air pollutants or local contaminants. So the following table, it's something even higher in emission factors, as you can see. This is the open burning. So this is an important category within the waste sector in GHG emissions. But as well as we saw at the beginning, it's mainly the only category which is having SLCPs and air pollutant emissions out of methane, which is shared with solid waste disposal and wastewater treatment. So again, at the first section, we have the activity data that we need. Population in this case is the same than before. We are taking from previous parameters. Generation per capita the same. In this case, we are the mass balance of how much of waste is being treated in the that it's burned. The calculation of therefore how much municipal solid waste is burned per year. This is the composition of waste, which is taken from the IPCC recommendation, as you can see here in the notes. And then a big list of emission factors for all the streams within the composition of municipal solid waste that are being used for calculations. All of them are reported in the parameters tab, the tab that we reviewed at the beginning, and then are just printed out here for easier use. And again, emission factors not only for GHG emissions, but also for pollutants, air pollutants, and SLCPs are taken from the calculation in this row too. So we have at the first one part that it's biogenic emissions, which is non-fossil portion of emissions. So this is zero. Those are not accounted in any inventory. So all the biogenic waste emissions are not accounted, but they are informative if the country wants to include them. And these are recommended practice, but in this case, the country is not considering the biogenic emissions in the categories in the sectors. So we are just focused on the fossil emissions, and then here we have the results for each stream. We have, sorry. We have here the different values. These are the units. This is in emissions. Sorry, this is in CO2. This is only CO2, direct CO2. And then we have the emissions. This is the summary of only CO2 emissions, non-biogenic, just fossil emissions. We need to be accounted, but also we need to cover the emissions of others, methane and nitrous oxide, which is the same structure that we have reviewed before. And the calculations and formulas here are always detailed from where they were taken. Okay, so the final and end of this session, we have the wastewater. And in this case, I will begin for the nitrous oxide emissions. Again, we are needing some population, protein consumption data, which is this is the FAO stats. You can see the details later on here. And then again, we have GHG emissions on here. All the factors that we need to make the calculations that are made below, and the only emission factor for the pollutant that can be estimated here, which is the non-methane volatile organic compounds. In this case, we don't have the activity data needed to calculate this. The activity data needed to calculate this is the volume of wastewater produced. In this case, we just made the structure, but everything is in zero. So in case in the future we can have the volume of wastewater that is being produced, then we will be able to calculate the non-methane volatile organic compounds emitted here in the wastewater treatments. So the structure is the same, always noticing that we have different emissions. Yes, so in this case we have the nitrous oxide here, which is the tab, and we have just taken the methane emissions from the other tab, the previous wastewater methane tab. You see here, which is just for printing it here, but it's not a calculation itself, just taken from the previous tab. So this is the final tab we will see. This is the methane emissions of wastewater treatments. And again, we need the population as a simple data, activity data, but we need many emission factors to use here. So at the beginning, these are some middle calculations, and this is middle factors that we need to obtain one activity data, which is the total organic in wastewater. As you will be able to see the formulas, you will be seeing from how they are being calculated. So this is just a summary of what we need in this case. So firstly, we need to have some activity data related to, at first, the emission factors, of course, and then activity data according to which is the fraction of population for each incoming group, how much people is rural population, urban high income or urban low income in the country, within the country. And also, for example, for each income group, in this case, this is just rural, how they are treating their wastewater. So this is a proportion, and everything should be summing up 100%. This is for rural. This is for urban high income group, and this is for urban low urban group. So taking all of this in consideration, we have all the population using in different number and in different alternatives their treatments to wastewater. And then including the emission factors by default, and including the emission factors of which is the impact of each wastewater treatment. Then we can have the middle calculations that will be used at the end in here. So this is the way how it is being calculated. This is the equation, and this equation it's made from you can see the equations here. We are using the 6.3 or the equation 6.1 and the equation 6.2. So all of these are supported in the IPCC guidelines and may explain further how these calculations are being done after the methodology is understood. In this case, then, when we are having all the methane emissions, we are able to convert them to CO2 equivalent emissions using the global warming potential, which is again in the parameter tab. So this is from my side. I would like to now hear from you. We have minutes still to develop a discussion and to answer some questions. So please open your video maybe and microphone, or raise your hand. I'm trying here to see all of you.
Hi.
Hi, Tabile.
Hi, Diego. How are you?
I'm fine, thank you. Nice to see you.
Fine, thanks. Yes, same here. Thank you for the presentation. Hi, Deepa. Hi, everyone. Thank you for the presentation. I just wanted to say I was also following up. I may not have many questions because I was also involved in the process, but I just wanted to say thank you for the detailed training.
Thank you, Tabile. Yes, sure. Probably compilers will raise some doubts when future calculations will be done, and we will be always open and available to answer the question that may arise in the future. The idea is this session is being recorded, so the compilation files for both sectors and the tool in the waste sector for solid waste disposal sites are being shared too. So all the information will be there, and any doubts or comments or observations that will arise in the future, we will be always open and available to answer them. So good question, no question. It's good from one side. Maybe it's really well explained, or it's very bad explained. I hope it's the first, more about the first. And probably people will raise the question to our mails if they want to. So you have our contacts, and you are able to share them if anyone wants to ask something to us. So thank you for your words, and hope this is covering what is expected in the capacity building of the use of the tools.
Yeah, I think from my side it was quite clear, and of course it's biased because I've used the tool before, but I'm hoping that if people have got questions, they have access to your emails where I can also assist. I'm also available, at least from a local context.
Thank you, Davile. Thank you very much. I don't know if probably we will not receive questions so far. I don't know, Deepa, if you want to open your microphone.
Yeah, no, I think it went well. You've taken us through the presentation very well, and I can see in the chat that some stakeholders have offered to engage further if you have further questions. And, yeah, we look forward to completing this activity and bringing it to a completion very soon, so that it can feed into the final NDC document. So well done, Diego and team. It's really nice to see this. Thank you.
Thank you, Deepa. Thank you for your words. And of course, we are still available to. We have some job still to some work to do, so we will be in contact. Thanks. So
I think if there are no further interventions from stakeholders, let us be in touch by email. I think all the stakeholders have Tabile's and your emails, so, and also mine, so they can be in touch, and if anything comes, we'll pass it on to you.
Sure, yes, right. So that's from my side. Thank you very much for your attending, for your listening to me. I felt for a while a bit alone here. I hope I've been presented here in personally would be much better, but at least we will be able to do that. So thank you very much. I'm very happy to assist you on this. I don't know if Gerardo wants to say final words. Thank you, everybody. Good afternoon.
Thank you, Diego. No, great job. Just to highlight that even after this technical assistance is over, we will be available in the future, because I mean the main idea is that this work keeps building on, right? I mean the next update of the inventory hopefully is based on this work and not started from scratch again. So we will be available for sure in the future, not only in the next couple of months, but whenever Eswatini decides to update the next inventory, and if there are any questions about the spreadsheets or the methodology that we use, we will be always there to answer those questions. So no worries that maybe today there are no questions, but maybe in the future. So we will be there to assist you. Thank you very much.
Thank you so much. That is very well noted. Definitely, we will be happy to work with you again. So wishing you all the best, but we'll be meeting again on the 6th, the day after tomorrow. So thank you very much, and thank you, stakeholders. See you on the 6th. Okay. Bye. Bye, everybody.
Bye. Good afternoon.
Bye.
Bye. Have a great day. Bye-bye.
That's what I can just say.